Okay, so we're going to try and graph this function here, log based e of x squared plus 1 divided by x squared plus 1 itself. So we need to find out some parts of the graph which we can work out and then link them up and hopefully get the continuous curve for the log base e of x squared plus 1 over x squared plus 1. So first of all, we need to find out what happens when x equals 0. So when x equals 0, we're going to find where we will intersect the y-axis. So let's just plug in 0 for x and see what happens. So I'm going to assign f of x as log, now we know it's log based e, so I'm just going to write log for now, x squared plus 1 over x squared plus 1. So now when x equals 0, we want to know what f of 0 is. So log, now we're quite lucky here because when you're dealing with 0, you've got to be careful with logarithms because log 0 is undefined. But here we've got plus 1 in there, nice little safety net. So 0 squared plus 1, and then that's divided by 0 squared plus 1. Okay, so this logarithm here, the input here is 0 squared plus 1, which is going to give us a log of 1. And then we're going to divide that, 0 squared plus 1 is just 1. So we know that this is defined and this is going to be 0. So when x is 0, y is also 0. So therefore it crosses through the origin. So at some point the graph is going to go through this point here. Next thing we need to work out is when what happens if we set this whole thing to 0. So what we're looking for is when does f of x equal 0? Well, we know when the whole thing equals 0, we've just done that because f of x is 0 when x is 0. So that is at the point x equals 0. So this thing actually goes through the origin fine, that's okay. Okay, now what about when x goes to infinity? So x approaches infinity, and what we want is the limit. So the limit as x approaches infinity. So we're going to have, plug infinity for x here, log of infinity squared plus 1. I know that's a little bit scruffy notation, but just so as we can see what's happening. And infinity squared plus 1. Okay, well, we'll see here, this input here will just be infinity. Infinity squared plus 1 is still infinity. Infinity squared plus 1 is still infinity. But the bottom will grow faster than the top. So therefore, the limit as x approaches infinity is going to be 0. So it's going to approach 0 as x approaches infinity. So as we're coming out here, it's going to do something here. And as it goes out to infinity, it's just going to get closer and closer to 0. And that will be from the positive side. Okay, what about as x approaches negative infinity? Right, so, well, negative infinity, let's just plug that in. Log of negative infinity squared plus 1 over negative infinity squared plus 1. Well, this is just going to yield the same answer as we got here. So negative infinity squared is going to be a positive number squared. So that's good for the logarithm, so it's going to be defined. And negative infinity squared on the bottom will give us also a positive. So it's always going to be positive as it approaches negative infinity, the same as when it approaches positive infinity. So when we're coming out here, it's going to approach negative infinity from the positive side. Okay, next we need to find the turning points. Okay, so now finding the stationary point of our function, we need to take the derivative of f prime. So, sorry, the derivative of f, which is f prime. So for this, as we've got a fraction, we need the quotient rule. So for the quotient rule, we'll go uv prime. So our u will be this log and our v will be this x squared plus 1. That equals, it's going to be another quotient which has a v squared on the bottom. So the denominator is squared. Then in the numerator, we've got u prime v minus u v prime. So it's looking a little bit like a product rule, but with a minus sign inside. Okay, now let's assign our u and our v. So u is log of x squared plus 1. And from here we can see we're going to need the derivative. So let's take the derivative of this, and we're going to need the chain rule, because we've got a log and a function inside the log. So the derivative of the log is always the reciprocal of the input of the log. So we've got 1 over x squared plus 1. And then we multiply by the derivative of the input of the log. That'll be the chain rule. So derivative of x squared plus 1 is just 2x. So 2x over x squared plus 1. And now our v, that's simply x squared plus 1. And our v prime is just 2x. Take the derivative of x squared plus 1, 2x. Okay, now let's plug into our formula here for finding the derivative of f. So now I'm going to go f prime of x equals u prime, which is 2x over x squared plus 1. Bearing in mind I'm still in the numerator, so that's going to be bracketed and there'll be a fraction underneath. And then subtract, so I still need to multiply by the v, don't forget that. So multiply by x squared plus 1. So that's essentially, if I put that over 1, makes it easier to understand. And then u is log of x squared plus 1. And our v prime is 2x. So that's our numerator. It's looking a little bit messy. And then our denominator is v squared, which is x squared plus 1 squared. Okay, let's simplify this up a little bit. So these two will cancel out. So that's just going to leave us with our 2x. And then here we've got log of x squared plus 1 times 2x. Nothing we can do to simplify that. But I'm going to bring my 2x to the front. And then that's still over this squared term on the bottom, x squared plus 1 squared. So that's the value of our stationary point. So I'm going to write that on here. F prime of x is 2x minus 2x log of x squared plus 1 all over x squared plus 1 quantity squared. Okay, I'm going to rub this off the board now, and then we're going to find the value of our derivative at x equals 0, thus finding the turning point, and then help us to construct our graph. So that's going to be next. Okay, now let's find our turning points. So we need to find when this derivative is equal to 0. So f prime of x equals 0. That's our goal at this stage, to find our turning points. So we want 2x minus 2x log of x squared plus 1 all over x squared plus 1 squared, and set that to 0. Okay, first of all we can multiply both sides by x squared plus 1 squared. So let's just do that. So if we multiply the whole function by that, this one will cancel out, and 0 times this will still be 0. So now we're left with 2x minus 2x. I'm going to leave those brackets out this time. Log of x squared plus 1, and that's all set to 0. Okay, now I'm going to subtract 2x from both sides. So minus the 2x here and minus 2x here. That's going to leave us with minus 2x log of x squared plus 1. These two are going to cancel out, and that's going to set us equal to minus 2x. Okay, now what we do is let's get this 2x and divide both sides by the 2x, and as we've got a minus, we might as well divide by minus 2x. So minus 2x minus 2x, and that's legit because the log is multiplied by the 2x here. So then we're going to have these cancel out, and this is just going to become 1. So now we've got log of x squared plus 1 equals 1. Okay, a little bit awkward here because we've got the x squared encased into the log input. So we need to get rid of this log. So the way to do that is use the inverse of log, which is the exponential. So I'm just going to write an e here as if I was writing that function as it was, and I've not changed the equality at all. It's still equal. So now we'll get, these terms will cancel out because e and log are inverse. So now we're left with x squared plus 1 equals e. Now we've got a chance to get the x on its own. Subtract 1 from both sides. X squared equals e minus 1. X equals square root of e minus 1. But not forgetting there is two values. So square root will leave us with plus or minus. So that's the value of our turning point when x equals the square root of e minus 1. So x equals square root of e minus 1, and there's one on the positive or negative side of the x-axis. Okay, right, let's take this off the board and plug this into our function and see what the value of our point on the y-axis is for these two values. Okay, so we want the value at, let's do the positive one first, square root of e minus 1. So f of square root of e minus 1. So plug in square root of e minus 1 for all our x's. So we've got log. So our x is squared here. So just a little, I'll do a square bracket so we can see it easily. E minus 1 quantity squared, and then plus 1. Close that into our log input. And then this term again squared. So this time I'm just going to write it like this. Plus 1. Okay, let's get rid of the squared term and the radical. So now we've got log. Now if we square this term, the radical will cancel out. So log of e minus 1 plus 1. So e minus 1 plus 1. And then here we've got the same in the denominator. This squared and radical will cancel, so we're left with e minus 1 plus 1 again. Okay, well that's quite handy because minus 1 and plus 1, they will cancel out. So now we've got log of e over e. Now log of e is just 1. They're inverse functions, so they will give us 1. And then e will just stay as e. So you could also write that as e to the minus 1 if you wish. So our value of the y-axis is at e to the minus 1 or 1 over e. Now those of you that are interested, 1 over e, it's approximately the value of 0.37 so on. And the square root of e minus 1 is approximately 1.31, and the negative square root of e minus 1 is obviously negative 1.31 approximately. Okay, now do I need to plug in the square root of e minus 1 to the negative? Well, we'll be just wasting our time because once we square the negative, we end up with the same as the positive anyway. So these values here of f of minus square root of e minus 1 would also be 1 over e. So I'm just going to write that here just for our information. And we know that this graph is going to be continuous everywhere because the log will never become undefined and this will never be 0 because we've got a plus 1 in the bottom. And in real numbers, x squared can never be minus 1 unless it's a complex number. So we know that this graph is continuous everywhere. So therefore we can go straight ahead now and we can start plugging in some values. So we said as x approaches infinity, the graph approaches 0. So it's going to come in and always be on the positive side of this x-axis on the positive side. And as x approaches negative infinity, it is also the same. It also approaches 0 from the positive side. So that's also going to come in like that. Okay, so next thing we need to know is the turning points. So the turning point is at the square root of e minus 1 and the negative e minus 1. So those we know are approximately 1.31. So if I just put that somewhere here, and I'll say that's the square root of e minus 1. And then this one, try and keep the same distance, try and keep it symmetrical, minus square root e minus 1. Okay, now the value at this square root of e minus 1 is 1 over e, so that's 0.37. So it's going to be not too high, it's going to be somewhere here. So I'm going to write that 1 over e. And the same on this side. So the graph is going to come up, definitely touch there. Let me just draw that better because I want that to be clearly the highest point of the graph. And the same here. Okay, now what we know is it comes down to the point 0. Now we know it doesn't cross the x-axis because this function can never be less than 0. So we know that this is now just going to come down to our origin. And as we can take the derivative of 0, we know it's continuous, so we want to make a nice continuous line there. So that's the graph of our function log of x squared plus 1 over x squared plus 1. Okay, and that's how it behaves.